A very good morning to everyone. Today we see about gear trains. First we are going to see about what is meant by gear train means. It's a combination of gear is simply is called as a combination of gears is called a gear train. Two or more gears are made to mesh with each other to transmit the power from one shaft to another shaft. That the combination is called the gear train. Okay. Gear train is simply called as the combination of gears uh, uh, used to transmit the power one shaft to another shaft. That is called as the gear train. Okay, let's go to the next slide. Now see about what are the types of gear trains. There are four types of gear trains we have. First thing is the simple gear train. Second thing is the compound gear train. Third is the riveted gear train. Fourth one is the epicyclic gear train. This is the four types of gear trains. Now we are going to see one by one. Okay. Now first of all, first we see about the simple gear train. It's simply called as when there is only one gear on each shaft. That means only one gear on each shaft. That is known as the simple gear train. Okay. See here, this is the one shaft. Have only one gear. That means driver. This is the driver gear. This one is the driven gear. It will be mounted on separate shaft. Okay, like this also one driver gears. It will be mounted on shaft. So this is the intermediate gear, which is also mounted on the single shaft. This is the driven gear. So it is also mounted on the single shaft. Like this also, gears one presented on only one gears on single shaft. Okay, that means the simple gear train. Okay. Now we are going to see about the what is meant by speed ratio, what is meant by train value. Here the speed ratio, that means, or it's also called as the velocity ratio. Okay, the gear trains is ratio of speed of the driver to speed of the driven. Okay, it is speed ratio is nothing but it's a ratio between speed of the driver and the speed of the driven is nothing but the speed ratio. And then the ratio of speed of any pair of gears is meshed inverse to their number of teeth. It's simply called as the any speed of the gears is inversely proportional to the number of teeth. Okay, here n1 is inverse proportional to t1. Here t2 speed 2. Here number of teeth 2. Okay, the ratio of speeds of gears in mesh is inverse of their number of teeth. Okay, is always the number of teeth is inverse to the gear ratio of speed. Okay, the train value, now we are going to see about the train value. The ratio of the speed of driven or follower to the speed of the driver is known as the train value of the gear train. Okay, that means the speed of the driven, that means driven means n2, and then its a ratio of n1 is equal to t1 by t2 is the train value. Okay, and now we are going to see about the when distance between the two gears is large and we need to constant velocity ratio. If you have any have a long distance between the two gears, at the time we need the constant velocity ratio. Okay, there are the motion from one gear to another in such a case may be transmitted by either following two methods. That means for transferring the motion one place to one another place, we are going to follow the two methods. First one, by providing the large sized gears. That means we use the large sized gears to occupy the required space. Otherwise we are going to providing one or more intermediate gears. Okay, now we are going to see the what is the difference between large sized gears are placed, otherwise intermediate gears are presented in this gear train. First method, providing large size gear, is very inconvenient and is uneconomical method. Okay, the first thing is it's very unconventional, that means it's not comfortable for use, otherwise it is have a lot of uneconomical method. It's increasing the economical things. Okay, and then second thing is the where the latter method, that means second method, providing one or more intermediate gears, is very convenient and economical method. Okay, it will be reduce the economical as well as to give the increase the power efficiency of the gear train. Okay, let's go to the next slide. We see about the intermediate gears. What is meant by intermediate gears? The intermediate gears are called ideal gears. Okay, as they do not affect the speed ratio or train value of the system. The intermediate gear is also called as the ideal gear. The intermediate gear does not affect any speed ratio or train value. Okay. First thing, to connect see first thing, to connect gears where the large center distance is required, the ideal gears is needed. It will be a large distance can be covered with help of ideal gears to obtain the desired direction of the motion of driven gear, if clockwise or anti-clockwise. Okay, next, go to the next slide. When the number of intermediate gears are odd, okay, that means single 1 3 5 7. Okay, when the number of intermediate gears are odd number, the motion of both gears, driver or driven, or follower like. Okay, that means if the number of gears are odd number, that means the gear motion will be like driver. If the driver is rotate clockwise direction, the driven also like that, otherwise the driver can be rotate on anti-clockwise direction, the driven also like anti-clockwise direction. Other than that, see here this is the driver gear, it will be rotated on the clockwise direction. This is the intermediate gear. Okay, this is on the driven gear. This will also the rotate in clockwise direction. In second thing, if the number of intermediate gears are even numbers, that means for here example for even number, that means we have the 4 number of pair of gears. Okay, the motion of the driven or follower will be opposite direction of the driver. See driver, see here driver gears is rotate on clockwise direction. These are the intermediate gears. Second intermediate gears are rotating an anti-clockwise. The third intermediate gear on rotating and clockwise. Here driven gear is rotated opposite to the driver. Okay, driver. Here anti-clockwise direction is rotating the driven gear. Here the input gear is in clockwise direction. This is the terms explained here. If the number of gears are odd numbers, it will be give the same rotation. If the number of gears is even numbers, that will be produce the opposite direction. The input is clockwise, means the output gets the anti-clockwise, or input is anti-clockwise, means the output get the clockwise direction. That's it. Okay, now going to the next slide. Here the speed ratio of the simple gear trains. Here we see about the speed ratio. Here the terms of number of gears, driver, and 2 and 3 as the driven intermediate gears. 4 now, number 4 will be the driven gear. Here N1 is the speed of the driver, that means N1 means speed of the driver. N2 means speed of the driven intermediate gear in RPM, revolution per minute. N3 is the speed of the driven or follower. Okay, T1 is the number of teeth on driver. Okay, T2 is the number of teeth on intermediate gear. T3 is the number of teeth on driven or follower. Okay, since the driving gear 1 is, that means driving gear 1 is meshing with the intermediate gear 2, that means this one is the driver gear. This driver gear is meshing with the second intermediate gear. Okay, and then intermediate gear 2, this is the intermediate gear 2 is meshing with the driven gear, is meshing with the driven gear 3. Okay, the speed ratio of gear train is called simply it's a relationship of the gear train. N1 it's a ratio between N1 by N2 equal to T2 by T1. Okay, is always inverse to the number of the number of teeth is always inverse to the number of speed. Okay, yeah, the speed is always inverse to the number of teeth. Okay, here N1 divided by N2 equal to T2 divided by T1. N2 divided by N3 equal to T3 divided by T3 divided by T2. Here multiplying this speed ratio, N1 divided by N2 into N2 divided by N3 equal to T2 divided by T1. Here in the end this N2 and N2 getting cancelled, so we are N1 divided by N3, and here T2 and then T2 getting cancelled, so N1 divided by N3 equal to T3 divided by T1. This is the speed relations and number of teeth relationship. Okay, it's of a simple gear train. Okay, this is the speed ratio of this formula for speed ratio of the simple gear train. The speed ratio equal to speed ratio of driver and then speed ratio of driven. It's a ratio between speed ratio of driver of speed ratio of driven equal to number of teeth on driven and the number of teeth on driver. Okay, the train value means the speed ratio of driven, ratio between speed ratio of driven and speed ratio of driver is equal to number of teeth on driver and the number of teeth on driven. Okay, and then we see